Hi everyone, so we're doing another video. This is the first video in the actual classroom, so I'm a little more professional, a little more collected, looks a little bit nicer. Let me get this chair out of the way. Alright, so this is video on 1.c.1, so we're going to start talking about the periodic table and periodic trends and how the periodic table can illustrate the structure of an atom and how the structure of the atom and the periodic table are really kind of linked together and how one describes the other and vice versa. So let me step out of frame here for a second, copy down these notes. This is supposed to be a periodic table, so if you have a periodic table, that's not your periodic table for tests, but if you have a periodic table, if you don't want to draw one, that's fine. I'm just going to color code that in a little bit. So let me hop out, copy the notes down, and I'll be back. Alright, so let's talk about the periodic table and periodic trends. So the periodic table is not just willy-nilly. They didn't just toss things onto a grid and just, oh, hey, it works perfect. What they actually did was the periodic table is based off of increasing atomic number. And it's outlined in a very specific way. So you have hydrogen up here, you have helium, and then lithium is right below the hydrogen. They did that for a very important reason. It turns out that the rows on the periodic table, we refer to them as periods, and Mr. Jacobson, our associate principal, told me that when I put something between dashes, it's something that you're supposed to know apparently, so it's almost as if I'm talking down to you, which is what I prefer to do when I can. Parents, I'm joking. I don't try not to talk down to your child as much as possible. Anyway, so rows are called periods, okay, so it's just what chemists refer to as a row on the periodic table, and it's the same thing as an energy level. So, if we think about it right here, if that is row 1, let me just kind of make a little line there, that's row 1, rows go across. This is everything, every atom in that row has one energy level. So, hydrogen, helium, one energy level. And if you don't know what an energy level is, you should watch the video on 1.b, talking about energy levels and electrons. So, first row, one energy level. Second row has two energy levels. Third row has three, and it goes all the way down to period 7. Okay, so lithium is right here. It's right underneath hydrogen because it has two energy levels. Okay, it has two energy levels. It has energy level 1 and energy level 2. That's two energy levels. Columns, groups, all right, chemists call them groups. You may also hear them called families, especially if you, let's say, go to college and have an older chemistry professor. Families are kind of the older name. We call them groups, the young hip chemists, which I, of course, am a member of. We call them groups. Groups are the number, let me get over here, the number of valence electrons in a neutral atom, okay? So if we're talking about column 1, columns, of course, go up and down. Column 1, every element in this first column has one valence electron in its outermost energy level. So hydrogen has one electron, period, so there's only one electron in its outermost energy level. Lithium has two energy levels, and in the second one, there's only one electron. Now, since those valence electrons dictate the reactivity and how these atoms react, everything in this first column will react in a similar way. The amount varies. For example, everything in this first column, with the exception of hydrogen, but all these metals in this first column react with water. They will burst into flames in water. Lithium reacts the least with the water, all the way down to francium, which would be very, very explosive in water. So they might have varying degrees of reactivity, but they all have the same reactivity. They all react to water. As we go over, like let's say group 2 has two valence electrons. So they all act in a similar way with different properties and things like that. And then you have these transition metals, which we will skip for right now. And then you have group 13, 14, 15, 16, 17, 18. Those all have 3, 4, 5, 6, 7, and 8 valence electrons in their outermost energy levels. 8 valence electrons being a complete octet is called an octet. Octet means 8. So it has a complete octet in its outer energy level, meaning that it'll be completely stable. Okay, so we need to talk about blocks in the periodic table. The periodic table is broken into several blocks. These blocks are based off of the orbitals in the outermost energy level. So, right here, this right here is the S block. Every element within this block has an S orbital. The S orbital is its outermost orbital. So these are spherical in shape, and they will react a certain way. They are highly reactive metals. All right, so this is the S block. S block. So they are highly reactive metals. Over here, in pink, this is the P block. Okay, this is the P block. Most of the elements in here are either nonmetals or metalloids. That's not an overarching rule. That's just a general trend. They are nonmetals or metalloids. They all have a p orbital. And what this means is that they have certain properties as well. Down here in the middle, these guys are transition metals. These are called the d block because they all end with an orbital in d. So they all have a d orbital in them. These transition metals are fairly stable. They are malleable, meaning that you can bend them. They will conduct electricity generally, magnetic, things like that. When you think of metals, you're thinking of D block metals. Iron, copper, zinc, chromium. Those are D block metals. And then last but not least, we have this lonely little guy over here. These are the lanthanide and actinides. These are the F blocks, because their last orbital is F. So these are the F block guys. Okay, so those are the blocks of the periodic table. There are a couple of trends present. Let's just talk about the trends, and then we'll be done with the video. Okay. Get rid of this. All right, so there are 4 main trends, and they're all based off of essentially how much an atom wants an electron. So I have my trends. Okay, so the first trend is ionization energy. Ionization energy is how much energy it takes to make an ion. Okay, we talked about this in a previous video. How much energy it takes to make an ion, or the energy, to strip an electron. So how much energy it takes to strip an electron. Okay, so if I have a natural atom of anything, I do need to apply some energy of some sort to strip off that electron. And that would be called the ionization energy. All right, radii, atomic radii. That's simply exactly what it sounds like. It's the size. It's the size. It's not really the size of the nucleus of the atom. We're really talking about the size of the electron cloud. Okay, you have to realize that the vast, vast, vast majority of the volume of an atom is the electron cloud. Very, 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 very little of the atom is actually nucleus. It's mostly the electron cloud. Excuse me. So when the electron cloud changes size, that's what really affects the size of an atom. And then 2 more. We have electronegativity. I'm just going to abbreviate electroneg. Electronegativity, how much an atom wants an electron, okay? Now it's really important to realize that atoms don't really have wants, needs, or desires. All they have is stable and unstable. So when I say how much an atom wants, I'm not really saying that it has human emotion. I'm not personifying my atoms. However, electronegativity is easiest thought of as how much an atom will, or how stable the atom will be when it gets an electron, or how much it wants that electron to be stable. Fluorine is the most electronegative, and francium is the least, and we'll talk about why in class. And last but not least, we have charges. All right, every group, the elements in every group have the same charges. So I know group 14 has a charge of plus or minus 4. I know group 15 has a charge of minus 3. Things like that. So based off of the group they're in, they will have similar trends, not the same, but they will have similar trends. However, it's easiest if we just kind of go through these trends together in class. We can annotate periodic tables and do things like that. So, all right, well, this was the video on periodic trends. The important thing to note is what a row is, what a group is, and how they correlate to the structure of an atom, and that the periodic table can predict properties of those elements because they kind of almost dictate the structure of the atom, or rather they illustrate the structure of the atom. And by knowing your periodic trends, you can know a lot about the element and how it will act and react. So I hope you all had fun, I hope you enjoy it, and I will see you in class tomorrow.